The sequence 6EQUJ5 represented a signal that started at 6 times the background noise, then rapidly rose to a staggering peak. The letter E stood for an intensity between 14 and 15 times the background noise. Q represented 26 to 27. The peak intensity, represented by U, was an incredible 30 to 31 times stronger than the deep space hum. The signal then gracefully fell back down, tracing a perfect bell curve as it passed through the telescope's narrow field of view. But it was the duration that was most stunning. Each character on the printout represented a 12-second observation period. The full duration of the 6EQUJ5 signal was 72 seconds. This was the exact amount of time the Big Ear's static design would take to observe a fixed, point-like source in deep space as the Earth rotated. It rose and fell in intensity precisely as expected if a transmitter from a distant star system had drifted through the telescope's beam. Struck by the sheer perfection of the signal, Eamon grabbed a red pen. In the margin of the printout, next to the stunning alphanumeric sequence, he circled it and wrote a single, heartfelt annotation that would give the event its enduring name: Wow. He had found something that looked, for all intents and purposes, exactly like the intelligent interstellar beacon that SETI had been searching for. Deconstructing the anomaly, the anatomy of a perfect signal. The initial excitement surrounding the WOW signal was immense, but it was quickly followed by intense scientific scrutiny. For a signal to be considered a genuine candidate for an extraterrestrial intelligence, ETI, it must possess certain characteristics that distinguish it from natural cosmic phenomena or terrestrial interference. The WOW signal didn't just meet these criteria, it seemed to be a textbook example. The first and most critical characteristic was its frequency. The Big Ear was listening to a range of 50 different 10 kHz channels centered around the 1420 MHz hydrogen line. The WOW signal was detected in just one of these channels, pinning its frequency very precisely. It was a narrow band signal. This is a crucial distinction because natural astrophysical sources, such as pulsars, quasars, or radio galaxies, emit radiation across a wide range of frequencies. Their signals are broadband, like cosmic static. Creating a powerful signal concentrated into a very narrow frequency band, however, is a hallmark of artificial technology. It is an efficient way to transmit information, akin to tuning a radio to a specific station rather than listening to all the noise at once. Furthermore, its proximity to the 1420 MHz hydrogen line was uncanny. It was slightly offset, but tantalizingly close to the universal waterhole frequency proposed by Morrison and Cocconi almost 2 decades earlier. An advanced civilization aiming to be heard would likely choose just such a frequency, knowing it would be a logical place for other astronomers to listen. The second key feature was its temporal profile, the 72-second bell curve. The signal was not a brief, random spike of static. It grew stronger, peaked, and then faded in a smooth, symmetrical pattern. This perfectly matched the observational window of the Big Ear. As the Earth rotated, the telescope's beam swept across the sky. Any point-like source from deep space would first enter the edge of the beam, low intensity, move to the center, peak intensity, and then exit through the other side, low intensity. A signal from an airplane, a satellite in orbit, or a ground-based source would have a completely different duration and profile. They would either be too fast, too slow, or not follow the clean rise and fall pattern. The 72-second duration was a fingerprint, strongly suggesting the source was stationary relative to the background stars, placing its origin far beyond our solar system. The third and most mysterious attribute was its location. The signal came from the direction of the constellation Sagittarius. This region of the sky is toward the dense, star-filled center of the Milky Way galaxy, a plausible location to find older, more advanced civilizations. However, There are no obvious, nearby sun-like stars or other notable astronomical objects in the precise patch of sky from which the signal originated. It seemed to be coming from a point of unremarkable emptiness, deepening the mystery. There was, however, one puzzling aspect of the detection. The big ear had two feed horns that scanned the sky side by side, with a few minutes' delay between them. A true cosmic signal should have appeared in the first horn, and then, a few minutes later, reappeared in the second horn as the Earth's rotation brought it into view. But the WOW signal was detected by only one of the two horns. The other horn heard nothing. Initially, this was seen as a potential flaw in the ETI hypothesis. It could suggest a glitch or a transient terrestrial signal that vanished before the second horn could see it. However, proponents argued that this wasn't necessarily a deal-breaker. The two horns had slightly different sensitivities and alignments, and it's conceivable a signal could have been detected by one and missed by the other if it fell in a null or was just at the threshold of detectability for the second horn. Another possibility is that the signal simply switched off in the few minutes between the two observations, a chilling thought that implied a deliberate timed transmission. Despite this single ambiguity, the combination of its narrow bandwidth, proximity to the hydrogen line, perfect 72-second duration, and extreme power made the WOW signal the most compelling SETI candidate ever recorded. The team at the Big Ear, led by Observatory Director John Krause and other astronomers around the world, immediately swung into action. The hunt was on to find it again. Decades of silence, the frustrating search for a repetition. A single unrepeatable observation is not science. It is an anecdote. To elevate the WOW signal from a tantalizing mystery to a confirmed discovery, it had to be detected again. Immediately after Jerry Amon's discovery, the team at the Big Ear repeatedly re-scanned the same patch of sky. They listened for days, weeks, and then months. They heard nothing but the familiar random hiss of the cosmos. The signal was gone. Over the subsequent decades, more than 100 follow-up observation attempts were conducted by astronomers worldwide, using far more powerful and sensitive instruments than the Big Ear. Robert Gray, an independent researcher who dedicated a significant part of his career to this search, used the Mega-Channel Extraterrestrial Assay array at Harvard and telescopes in Australia and Panama to monitor the location. He and others used the Very Large Array, VLA, in New Mexico, one of the most powerful radio observatories on Earth. Despite pointing these formidable instruments at the WOW signal's coordinates for hundreds of hours, they found only silence. The inability to redetect the signal became a central part of its legend. It implied one of two things. Either the signal was a one-time transient event, a celestial fluke or a brief directed transmission, or it was not from a fixed point in space at all. This lack of confirmation forced scientists to rigorously explore every conceivable alternative to the extraterrestrial hypothesis, no matter how mundane or complex. The process of elimination began, and a long list of potential culprits was assembled and systematically investigated. The first category of explanations involved terrestrial interference. Could the signal have been a stray radio wave from Earth? Military transmissions, experimental aircraft, or even faulty consumer electronics could potentially generate unusual signals. This explanation, however, fails on several counts. The frequency of the WOW signal falls within a protected spectrum, a band of frequencies internationally reserved for radio astronomy and explicitly forbidden for terrestrial transmissions to prevent this very kind of interference. While a secret or illegal transmission is not impossible, it is highly unlikely to have possessed the precise characteristics of the WOW signal. It would have had to be a powerful, narrow-band signal that happened to turn on, just as it entered the Big Ear's beam, and turn off 72 seconds later, all while perfectly mimicking the signature of a deep space source. The probability of such a coincidence is astronomically low. Another possibility was a terrestrial signal bouncing off a piece of space debris. An orbiting satellite, a spent rocket booster, or even a metallic meteor could theoretically reflect a ground-based radio signal back to the telescope. This scenario, known as a scintillating reflection, could potentially explain the transient nature of the signal. However, it too has problems. It would require a highly specific and unlikely alignment of a terrestrial transmitter, a piece of reflective debris, and the Big Ear telescope. Furthermore, the signal's characteristics, its stable frequency and clean, powerful profile, are not consistent with a chaotic, tumbling reflection from a piece of space junk. The signal would likely be smeared in frequency and fluctuate erratically in intensity. With terrestrial sources largely ruled out, attention turned to natural, albeit unusual, astronomical phenomena. Could some unknown celestial event have produced a signal that mimicked an intelligent beacon? One proposal was gravitational lensing. According to Einstein's theory of general relativity, the immense gravity of a massive object, like a star or a black hole, can bend and focus light and other electromagnetic waves that pass by it, acting like a cosmic magnifying glass. It is conceivable that a very distant, weak, and continuous natural radio source could have been momentarily amplified as a star passed in front of it from our point of view, creating a brief, powerful burst. While this is physically possible, it requires an extraordinary cosmic coincidence. It fails to adequately explain why the signal would be so uniquely narrow-banded, as natural sources are typically broadband. Another natural explanation is interstellar scintillation. Similar to how Earth's atmosphere makes stars appear to twinkle, the interstellar medium, the thin gas and plasma between stars, can cause distant radio sources to fluctuate in intensity. It was theorized that a weak but continuous signal could have been a twinkle of extreme intensity that lasted for 72 seconds. Again, this hypothesis struggles to explain the narrow-band nature of the signal and the fact that such a dramatic scintillation event has never been observed from that direction since. For decades, every proposed explanation, from secret military satellites to exotic astrophysical events, was found wanting. They each failed to account for the full suite of the WOW signal's peculiar characteristics. The alien hypothesis, as improbable as it seemed, remained the explanation that best fit the data. The mystery deepened, and the signal stood alone as a monument to the unknown. The comet hypothesis, a bizarre new twist, and its refutation. For nearly 40 years, the WOW signal remained an unresolved enigma, with the leading explanations hovering between an undiscovered natural phenomenon and a genuine ETI signal. Then, in 2017, a dramatic new theory emerged that promised to finally solve the puzzle once and for all. Antonio Paris, a professor at St. Petersburg College, proposed a novel and completely natural explanation. The signal was generated by a comet. His hypothesis was based on a simple fact of cometary physics. Comets are essentially dirty snowballs of ice, rock, and dust. As they approach the sun, the solar radiation causes the ice to sublimate, releasing a massive cloud of gas and dust that forms the comet's coma and tail. This cloud is rich in various molecules, including a vast halo of neutral hydrogen. This hydrogen, Paris argued, could emit radio waves at or very near the 1420 MHz frequency detected by the Big Ear. The core of his argument rested on two specific comets, 266P Christensen and P2008 Y2 Gibbs. These comets were not discovered until 2006 and 2008, respectively, so they were unknown in 1977 and had not been considered as a possible source. Paris used astronomical software to rewind the clock, calculating the comet's orbits back to August 1977. He discovered that on the night of the WOW signal, one or both of these comets were in the general vicinity of the sky where the Big Ear was pointing. The comet hypothesis was immediately compelling because it seemed to explain many of the signal's strange properties. The The hydrogen cloud surrounding a comet would naturally produce a signal near the hydrogen line frequency. Because a comet is a moving target, its signal would not be detected in the same location again, explaining the failure of all follow-up observations of that fixed point in the sky. It was a natural, testable, and non-ETI solution that tidied up the 40-year-old mystery. The story was widely reported in the popular press as the definitive debunking of the WOW signal. The alien beacon, it seemed, was just cosmic gas. However, the scientific community was far from convinced. As astronomers and physicists scrutinized Paris's proposal, significant and ultimately fatal flaws emerged. The scientific process, with its rigorous peer review and counter-analysis, swung into action, and the comet hypothesis quickly began to crumble. The first major issue was the strength of the emission. While it is true that comets release hydrogen, the physical process by which this hydrogen would emit a powerful, narrow-band signal at 1420 MHz is not well supported. The amount of energy required to generate a signal 30 times stronger than the background noise, as the WOW signal was, is enormous. Cometary hydrogen clouds are simply not known to be radio-loud sources of this magnitude and type. Radio astronomers who had studied comets for decades stated that such a powerful emission from a cometary coma was physically implausible. The second problem was the signal's profile. The WOW signal had the distinct signature of a point source, meaning it came from a very small, concentrated area of the sky. The 72-second bell curve was a direct result of this. A hydrogen cloud surrounding a comet, however, would be a large, diffuse source, spanning a much wider area of the sky. A signal from such a diffuse source would not have produced the sharp, clean rise and fall seen in the big ear data. It would have had a much flatter, broader, and messier profile as the telescope's beam scanned across the extended cloud. The third and perhaps most damning criticism came from a detailed reanalysis by the original team at the Ohio State University Radio Observatory. They pointed out a crucial detail about the 1977 detection. The two candidate comets were not actually within the Big Ear's observational beam at the precise time the signal was recorded. They were in the general area, but were offset enough to have been missed. Furthermore, they pointed to the conundrum of the two feed horns. If the signal came from a vast, diffuse comet cloud, it should have been detected by both of the Big Ear's horns, not just one. The fact that only one horn saw it strongly argues against a large, extended source like a cometary cloud and reinforces the idea of a compact, point-like origin. In response to this wave of criticism from the astronomical community, the comet hypothesis was largely abandoned. While it was an intriguing and creative piece of scientific detective work, it simply did not hold up to the evidence. The definitive solution had been debunked. The process had come full circle, demonstrating the self-correcting nature of science. The debunking of the debunking left the WOW signal an enigma once more. It was not a comet. It was not terrestrial interference. It was not any known natural phenomenon. The mystery, far from being solved, had deepened. The bizarre natural explanation had turned out to be less plausible than the original, more profound mystery it sought to replace. A new clue, identifying a potential sun in the emptiness. With the leading terrestrial and natural hypotheses largely discredited, the WOW signal regained its status as a premier ETI candidate. However, one of the enduring challenges had always been its apparent origin in a blank patch of sky. Without a specific star system to point to, it remained an abstract anomaly. This changed dramatically in 2022, thanks to the power of big data and a determined amateur astronomer. The European Space Agency's Gaia spacecraft has been meticulously mapping the Milky Way since 2013, measuring the positions, distances, and motions of over 1 billion stars with unprecedented precision. This vast catalog of celestial data provides a powerful tool for re-examining old astronomical mysteries. An amateur astronomer named Alberto Caballero decided to use the Gaia database to undertake a search that was impossible in 1977. to find potential sun-like stars located within the original search area of the WOW signal. The original coordinates of the signal were not precise, covering a patch of sky larger than the full moon. Sifting through this region for potential candidates had been a daunting task, but with Gaia's precise distance measurements, Caballero could filter the thousands of stars in the region, looking for ones that matched a specific profile, G-type or K-type stars, which are similar in size, temperature, and luminosity to our own Sun. These are considered the most likely candidates to host planets with liquid water and, therefore, life as we know it. After a meticulous search through the Gaia data, Caballero identified dozens of potential candidates. However, one star stood out from all the others. A G-type star designated 2MS 19281982264123. This star, located approximately 1,800 light-years away in the constellation Sagittarius, was found to be a near-perfect solar analog. It has a temperature, radius, and luminosity that are remarkably similar to our Sun. Of all the stars in the WOW signal's error box, this one was the most compelling Sun twin. This discovery does not prove that the WOW signal originated from a planet orbiting this star. It is circumstantial evidence, a correlation. However, it is an incredibly powerful correlation. For the first time in nearly 45 years, there was a specific, plausible address for the mysterious transmission. The signal was no longer just a direction in space. It was now anchored to a sun-like star, the exact type of place Frank Drake and other SETI pioneers had proposed as the most likely home for a technological civilization. The identification of 2MS 1928198226400123 has re-energized the search. It provides a concrete target for future SETI projects. Now, powerful instruments like the Allen Telescope Array, the Green Bank Telescope, and potentially even space-based observatories can be directed with high precision at this specific star system. Scientists can listen for new signals and even search for indirect signs of technology, such as the chemical signatures of industrial pollutants in the atmospheres of any planets discovered orbiting the star, a technique known as searching for techno-signatures. The mystery of the WOW signal has transitioned from a historical curiosity to an active, targeted investigation. We may still not know what it was, but we now have a leading suspect for where it came from. The quest to solve this 72-second enigma has a new focus, transforming a cold case into a live investigation. Conclusion: the legacy of a 72-second whisper. Nearly half a century after it was first recorded, the WOW signal endures not as a solved puzzle, but as a profound and motivating scientific mystery. It remains the most powerful, most tantalizing, and most persistently unexplainable candidate for an extraterrestrial signal ever detected. Its journey through the annals of science is a case study in the scientific method itself. A story of discovery, of excitement, of rigorous skepticism, of plausible but incorrect theories, and of the persistent quest for evidence. The signal's legacy is twofold. First, it stands as a singular, powerful piece of data that resists all easy explanations. Every attempt to attribute it to mundane sources, from terrestrial interference to cometary gas clouds, has failed to withstand scientific scrutiny. Its characteristics, the narrow band, the specific frequency, the temporal profile matching the telescope's design, the sheer power, continue to align more closely with the theoretical fingerprint of an artificial, intelligent source than any known natural phenomenon. While science rightly demands repeatable evidence, the unique perfection of this one-time event forces us to keep the extraordinary possibility on the table. Second, the WOW signal fundamentally changed the field of SETI. Before 1977, the search was predicated on finding continuous, steady beacons. The WOW signal proved that we might be searching for something entirely different: brief, powerful, transient flashes. This realization has shaped modern SETI strategy. emphasizing the need for all-sky monitoring and rapid response systems that can immediately pivot to observe a new detection with multiple instruments. It taught us that an alien hello might not be a continuous broadcast, but a fleeting, one-time pulse. We may never know with absolute certainty what sent that 72-second message across 1,800 light-years of space. Was it a powerful beacon sweeping the galaxy, which we just happened to cross at the right moment? Was it leakage from a powerful interstellar propulsion system? Or was it something else entirely, a natural phenomenon so rare and exotic that we have yet to imagine it? What we do know is that the mystery continues to inspire. The single word, wow, scrawled in red ink on a data printout, encapsulates the human spirit of exploration and wonder. It represents a moment when the vast, cold silence of the cosmos seemed to wink back at us, offering a fleeting hint that we might not be the only ones asking the big questions. The search for answers continues, fueled by that 72-second whisper from the stars. We are still listening. In the vast, silent expanse of the cosmos, humanity has long cast a hopeful ear, listening for a whisper, a sign that we are not alone. For decades, this search, a monumental endeavor known as the Search for Extraterrestrial Intelligence, SETI, was met with an unwavering, profound quiet. But for 72 fleeting seconds on a summer night in 1977, that silence was shattered by a signal so powerful, so peculiar, and so perfectly aligned with our expectations of an alien beacon that it has defied explanation for nearly half a century. It was a cosmic shout from the void, a burst of energy that left behind a single tantalizing word on a computer printout. Wow! This is the story of that signal, a journey into a mystery that has deepened with time, leading us to question our initial assumptions and pointing us toward an even more bizarre and compelling cosmic puzzle. It is the story of a transient whisper that has become one of the most enduring enigmas in the history of science. The Great Cosmic Conversation, setting the stage for SETI. Before we can comprehend the true significance of the wow signal, we must first understand the context in which it was detected. The search for extraterrestrial intelligence is not a new human fascination. It is as old as our awareness of the stars themselves. But it was only in the 20th century that this philosophical quest transformed into a scientific discipline. The dawn of the radio age provided humanity with a new set of ears, capable of hearing the invisible symphony of the universe. The modern era of SETI began in 1959 with a seminal paper in the journal Nature by physicists Philip Morrison and Giuseppe Cocconi. They argued that if other intelligent civilizations exist, they might be trying to communicate across interstellar distances using radio waves. They proposed a specific, universally significant frequency for this cosmic conversation: 1420 megahertz. This frequency corresponds to the electromagnetic radiation emitted by neutral hydrogen atoms, the most abundant element in the universe. It is a natural, fundamental constant, a cosmic signpost that any technologically advanced civilization would presumably recognize. This region of the radio spectrum became known as the water hole, a quiet cosmic oasis where intelligent species might metaphorically gather to exchange information. Inspired by this idea, a young radio astronomer named Frank Drake conducted the first practical SETI experiment, Project Ozma, in 1960. Using the 85-foot radio telescope in Green Bank, West Virginia, he pointed his instrument at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, listening intently at the hydrogen line frequency. While Project Ozma detected no confirmed signals, it lit the fuse for a global scientific endeavor. To provide a framework for the search, Drake developed the now famous Drake equation, a probabilistic argument used to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. The equation multiplies a series of factors: the rate of star formation, the fraction of those stars with planets, the number of planets that could support life, the fraction of those on which life actually appears, the fraction of life that develops intelligence, the fraction of intelligent civilizations that develop detectable technology, and finally, the length of time such civilizations release detectable signals into space. The Drake equation is not a tool for calculation, but a tool for thought. It elegantly organizes our ignorance, highlighting the specific questions we need to answer to understand our place in the universe. At its heart lies the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Given the vast number of stars and potentially habitable planets in our galaxy and the billions of years of cosmic history, it seems statistically probable that other civilizations should have arisen. Some of them would be millions of years older than our own and should have had ample time to colonize the galaxy, or at least make their presence known. Yet, the cosmos appears silent, empty. This profound contradiction is known as the Great Silence. It is against this backdrop of theoretical promise and observational silence that the WOW signal arrived. It was not just a random noise, it was a signal that seemed to check all the boxes that pioneers like Morrison and Drake had theorized. It was a needle in a cosmic haystack, a potential answer to Fermi's haunting question. The Big Ear and the Night of Discovery. The instrument responsible for detecting the WOW signal was Ohio State University's radio observatory, affectionately known as the Big Ear. Built in 1963, the Big Ear was a marvel of cost-effective engineering. It was not a conventional steerable dish, but a stationary telescope that used the Earth's rotation to scan the sky. It consisted of a massive, flat, tilting reflector the size of 3 football fields and a larger, fixed parabolic reflector. As the Earth turned, a slice of the sky would drift through the telescope's focus, where 2 horn-like receivers, or feed horns, listened for signals. This design meant the Big Ear couldn't track a source or immediately re-observe a detection. It got 1 pass per day at any given point in the sky. From 1973 until its dismantling in 1998, the Big Ear was dedicated to the world's longest-running SETI program. The data it collected was not analyzed in real time by a team of bustling scientists. Instead, it was processed by an IBM 1130 mainframe computer and printed onto long, continuous sheets of fan-fold paper as a series of alphanumeric characters. Volunteers would then manually inspect these reams of printouts, searching for anything unusual. On August 15, 1977, the Big Ear was listening, as always, to the silent symphony of the cosmos. A few days later, a 37-year-old volunteer astronomer named Dr. Jerry Amon sat down for his routine task of reviewing the latest batch of data printouts. As his eyes scanned the columns of numbers and letters, a specific sequence from August 15th leaped off the page. In Channel 2 of the data, he saw the characters 6EQUJ5. To the untrained eye, it was gibberish. To Amon, it was breathtaking. The system used a simple code to represent signal intensity or signal-to-noise ratio. A blank space represented a very low-level background noise. Numbers 1 through 9 represented signal strengths 1 to 9 times greater than the background noise. Once the intensity surpassed 9, the alphabet was used, with A representing an intensity of 10 to 11 times the background, B representing 11 to 12, and so on.